Welcome to the Introduction to TypeScript workshop brought to you by Emergent Works, being hosted by current Emergent Works mentor, Josh Goldberg. One time for Josh. Welcome, welcome.
Let's get it. Let's get it.
Absolutely. So, today is really just, this workshop is our way of being able to provide some excess resources to some of the things that will need to be better technologists in our fields, no matter what the particular career path is. And TypeScript is a programming language that we're probably going to meet along the way. So I don't know much about it. I'm not going to give you like some intro about TypeScript because I'm here to learn as well. And when we can learn as a community, we all do better. So with no further ado, Josh, take it over, my man.
Well, thank you so much. Thanks for having me. Hi, everyone. I'm Josh. Emergent Works is awesome, and we should all be involved as we are. TypeScript is really cool. I like it a lot. You don't have to learn every latest and greatest web technology to be a front-end, back-end, whatever developer, but TypeScript is really useful. And if you want to learn it, it can give you a lot of good benefits. Also, a lot of companies like it, so it's good for gaining employment. The way this is going to work is I'm going to start presenting some slides soon, and I'm going to bounce between slides and a repository that's on GitHub. Please interrupt on the Zoom chat whenever you have any questions. If something's not clear, if you have some random thing that you think might be related, ask any questions in the chat and we'll get to it very quickly. And everything will be available after this. So if you don't feel like rewatching the recording, it'll all be on GitHub and posted in the Slack. Sound good? Yeah. All right. So hello, I'm Josh. And I'm still getting used to my current computer setup. So the agenda for this is I'm going to go over the setup, like how to install TypeScript, how to use this workshop a little bit. We're going to talk about what TypeScript actually is, like why do we have this thing? How is it different from JavaScript? I'm going to go over some of the core features of TypeScript, why it exists, and then the actual syntax features. And I'm going to leave a heck of a lot of time at the end for an AMA. You can ask me whatever you want. Previously, people have asked about like things that I didn't cover well or at all in the talk, or I have this weird thing with my project. How can TypeScript work with it or help me? But whatever you want to ask about, all you. We have like almost 2 hours, so we should have time. So few ground rules to start off. It's okay not to understand everything immediately. I definitely recommend focus on the concepts, not so much the syntax. As anyone who's learned to code can attest, you're going to mess up the semicolons and the squigglies and the dashes and all this. But the real important stuff is, how is TypeScript different from JavaScript? What's a type system? What's a type? That type of thing. Everything is available online, and you can always ask me or just in general on Slack if you want the resources here or more resources like the TypeScript docs. I also recommend, don't worry if you only get some of it. It's physically impossible for the human brain to learn a bunch of different topics at the same time. So it's okay. And if you haven't yet, highly recommend get some version of Git and Node, and then an IDE, an editor like VS Code, my personal favorite. And the slide, it's PowerPoint, has notes that has links to downloads for those. But you don't have to. You can just watch if you don't have those things or don't want them. Cool. We're ready to start. Yay. A little bit about me. I don't have a job right now, but previously I did. I'm going to be a full-time open source maintainer next month, and I'm writing a book on TypeScript for O'Reilly. So I feel comfortable talking about TypeScript. And if you have any questions about TypeScript or open source or the web or getting a job, then happy to answer those two at the end. All right, TypeScript. It's been 10 minutes now. We're actually going to talk about TypeScript. Very exciting. You might have heard this catchphrase. This is pretty popular in the web. TypeScript is a typed superset of JavaScript. That is the technical definition of TypeScript. But what is that, and why is that important? To start, I'm going to, again, skip back to JavaScript instead of TypeScript. It was made in 1995. It was supposed to be a really basic web browser scripting language. It wasn't supposed to power all sorts of fancy applications and browsers and servers and whatever. And because of the nature of the web, where websites need to work in your browser and someone else's browser and everyone's browser back 5 years and 10 years and forward 5 years, it's super backwards compatible. We can't suddenly change JavaScript in a way that might make it a better language, because then old websites will break. That means that JavaScript can only really change in the types of syntax sugar it has, or things that compile down to old JavaScript features. Things need to be backwards compatible when they're changing. For example, let's look at the function on the top, greet person, which takes in two parameters, a first and a last name, and console logs, hello, first, last. Now, this string concatenation in the second line of code is kind of annoying and hard to keep track of, a lot of quotes, a lot of pluses. So people added a nice little feature called template strings in newer versions of JavaScript, where you have the backtick, hello, comma, and then $ squiggly to concatenate things together. And this is an example of syntax sugar. If you run a compiler such as Babel, it takes the bottom JavaScript, the newer version, and outputs the top version, the older JavaScript, so that older browsers and runtimes can still run it. If you set up an app with something like Create React App or Create Next App, it'll do this for you, so that old versions of Internet Explorer 11 and Chrome 60 can run it, as well as Chrome, whatever their version is now, 90 or something. So syntax sugar is nice. It makes the language more pleasant to work with, but it doesn't catch typos that well. It doesn't make the language more smart. And I'm just curious, did anyone here maybe catch the typo that greet person took in a single argument in the two places it's called, but the function is supposed to take in two parameters? It's really easy to lose track of what you're doing in code. You change a function and forget to change all the things that call it. So this kind of difficulty in development is a core fault, a core problem with languages like JavaScript that just provide you basic syntax and don't add a way to declare how things are supposed to work.
Wait, Josh, what's the typo?
Ooh, great question. Greet person right now is being called with
Oh,
one
okay,
thing.
got it.
See, this is hard to catch. I wouldn't have caught this. When I first learned or was shown a presentation on TypeScript, they had a similar thing in there and I didn't get it. Like the entire presentation, I was like, what? Why is that a problem? So this is why JavaScript is kind of hard to build big applications with, because this type of little typo can happen over and over and over again. And you're going to have to run the code if you don't suddenly somehow see it to find these issues.
Wait, but even a dynamically typed language would have caught that, yeah? Because it's one parameter rather than two. It would have expected two arguments and got one.
A language like Ruby, yeah, would have, but JavaScript doesn't care. You can run this in JavaScript and last will default to undefined, the second argument.
Oh, okay.
Right, because I was thinking it's not like so much of a typo. It's just that we don't have the second parameter and it's just going to come up as undefined.
Exactly. Oftentimes it's literally impossible to look at JavaScript code and know, is this a typo? Is this a mistake? Is this just a weird quirk? Maybe we want to say, hello, Josh Goldberg undefined. Like maybe that was the intent of the programmer.
Right.
JavaScript. By the way, I want to know, I actually can't see the Zoom chat while I'm in slides mode, but I'm about to switch to code mode. So sorry if there are 50 questions in the chat. Thank you for speaking out loud. Much appreciated. Anything else before I move on to the next stuff? Okie dokie. So I have a repo here. It's linked in the Slack. You can clone it, TypeScript intro Emergent Works. And I'm just going to quickly switch over to my Zoom setup. There we go. So in my repository, I'm just going to kill it so I can show you from the start. Clear git clone, HPS, github.com, Joshua K. Goldberg, TypeScript, intro, Emergent Works. Did I get it right? Yeah. And then CD, TypeScript, intro, Emergent Works, change directory to it. And then I really like VS Code. And for those who use it but haven't found this command yet, if you do code space and then a path to a folder, such as dot the current folder in your terminal, it'll open VS Code on that folder, which is awesome. And we have setup instructions right there. And the first one is npm I to npm install. That was very fast. Cool. We talked a little bit about this in the Slack, but I recommend as a next step npm I-g TypeScript, which installs a TypeScript package globally on your computer. npm install -- global is the full written out command. npm i-g TypeScript. If you, oops, I always forget. Sometimes you have to, if you're running on a Linux system, you have to do sudo npm i-g TypeScript to get it to be a global install.
Can we drop the link to that GitHub repo in the chat? Por favor?
Oh, good idea. Doing that right now. Boop. Thanks, good call. Alrighty. So now if you run tsc -- help in your terminal, it'll print out a whole bunch of information with a link to learning more in your terminal. Cool. I'm gonna wait a few more seconds in case anyone's still running, so I can grab coffee. Would anyone be offended if I moved on? Talked about TypeScript itself?
No, it might be worth noting that that code command doesn't automatically work with VS Code. There's separate installation you have to do for that to work.
Yeah, I was thinking the same thing.
Oh boy. You mean separate from installing VS Code?
Correct.
Oh, are you all on Macs?
Yeah.
Yeah.
Ah, right. I forgot about that. Thank you for the reminder. What is the command? So in VS Code on Mac, it's, what is it? Option-Shift-P to open the command menu or something like that. And then install path. See, I'm on Windows, which is, I'm not going to claim is in any way superior, but it does do the code thing install for you. But yes, alternately, if you have VS Code open, you can go File, Open Folder, and that'll give you the opportunity to open it somewhere. I used a Mac for work until recently, and now I'm on Windows again, and it's weird. I'm not used to it. Cool. TypeScript. So TypeScript really is two things. TypeScript is that superset of JavaScript, meaning it's JavaScript and also adds syntax for new things, letting you declare the types of stuff, whether something is supposed to be a string or a number or whatever. And it's also, on top of that, a suite of development tools that understand JavaScript and TypeScript code well enough to help you write them. It was mentioned previously that even in a dynamically typed language, shouldn't this greet person function something complain about it if you call it with one thing instead of two? JavaScript won't, but TypeScript by default would. TypeScript would tell you, if you run TSC, the Typescript compiler, on a file that has this greet function or greet person function and a line of code that calls it, it would yell at you, hey, you're supposed to pass two things. So the way you run that, the simplest, the one I like the most, is TSC, the npmi TypeScript thing we did. TSC stands for Typescript Compiler. So if you type TSC and then a path to a folder, it'll run TypeScript on the source code in that folder, any .ts file in that folder. So I'm just going to quickly switch back and do that now. Clearing my terminal, source/1.ts in VS Code, which is the function we saw on the slides. And if I do tsc source/1, TypeScript will yell at us that we expected two arguments, only got one. Look at those red squigglies. And the reason why it's complaining is that an argument for last was not provided. So yay, TypeScript is already finding maybe probably potential bugs for us. My favorite TypeScript command line flag, yes, I have favorites, is tsc, whatever the path is, -w, which turns it into a watch mode, which means that it'll keep rerunning whenever you change the file. So let's say I fix this file to say Josh, Goldberg, or like a name that's not mine. So someone from the Zoom call, sorry for making you famous now. And I save the file and voila. Now TypeScript sees that there were no complaints. Yay. So yay, TypeScript. And again, just to show it off, it's TSC path to thing it's running on -w. If you don't want to keep on typing source/1 or the path to what you want to run on, you can go into the directory and type tsc in that directory, and it'll default to the current directory. Oh, wait, no. They changed the behavior. Sorry. tsc source/1 -w. Forget I said anything. Cool. We might also note that TypeScript gets run in the background of most modern IDEs if they support TypeScript or have the TypeScript plugin installed for them. The red squigglies in VS Code show up in your editor, kind of like how Word shows you the little blue or green squigglies for like spelling or grammar. So greet person, if you use it with the wrong one, and you hover your mouse over it, it'll give you the little explanation of what's wrong. And it'll even have a link you can click to the offending line. It's just move my cursor there. And if you click this view problem, it'll give you this little, I think they call it a preview box, complaining about the thing. So that's TypeScript running on code. It's telling us that we probably made a mistake. You should fix it. Before I go into any of the TypeScript specific syntax or how one might tell TypeScript yes, this is allowed, any questions or comments, things people want to talk about? Cool. Moving on. I want to note that TypeScript is produced by Microsoft. Microsoft runs the project, but it's not a Microsoft specific thing. Back in the day, everyone hated Microsoft. Now, only some people hate Microsoft. Definitely an improvement for them. All major text editors, IDEs, have built-in support or a very popular, well-supported extension. Atom, Sublime, Emacs, VS. Oh, I have Sublime twice on there. Whoops. Vim, VS Code, whatever. VS Code's TypeScript plugin is also what it uses to give you development help for JavaScript, which is why sometimes when you write JavaScript, you see what appears to be TypeScript complaints in it or TypeScript suggestions. They're powered by the same engine. And TypeScript itself is not code you typically run. You don't run TypeScript code in the same way that you don't run C# code. Even if it feels like you're giving a TypeScript file or C# file to some command or program that's running it, what's actually happening is that it's getting compiled down to a format the command can run. So similar to how C++, C#, whatever the new things are, Rust, they all compile down to something that someone can run. TypeScript compiles down to JavaScript. If you ever use Dino, which is like a new version of Node.js, Dino seems to run TypeScript directly, but under the hood, it compiles it to JavaScript first. And I want to plug again that a lot of companies really like TypeScript. So if you want to make your resume stand out, adding TypeScript is a good tip. People eat that stuff up. Cool. So let's talk about TypeScript syntax. When I say TypeScript is a superset of JavaScript, what I mean is TypeScript adds a bunch of syntax to JavaScript at the language. So TypeScript can infer values from a variable. So let's say that you have a let my name equals Josh Goldberg, and then you try to console.log myname.len. That's not going to work because you haven't annotated. Sorry, you haven't 2.ts. You haven't declared my name as a variable that has a .len property. TypeScript here can infer that my name is type string. And this is the first piece of TypeScript syntax that I want to show off. This colon space is how TypeScript and a few other modern languages like Swift indicate to you or can be told that something is a type. And we're still not typing our own TypeScript specific syntax here. We are declaring a variable, my name, and then TypeScript infers, I'm hovering over it with my mouse, that my name is type string. So I'm going to quit TypeScript in this thing with Control-C, tsc source 2-w. Now that TypeScript knows and can tell us that this thing is colon space string, we can ask TypeScript to make sure we're doing it right. If we do myname.len, that's wrong because len does not exist on type string. But if we correct it to length, that'll work because string.length is number. But length can't be called in TypeScript. Length is just a number. It's not a function. And I can't tell you how many times when I'm switching between languages or learning a new language, I do like thing.length, thing.size, thing.length parentheses, len of thing, size of thing. So it's nice to have that little stability, especially if you're switching between two languages that have a totally different, like Python, Ruby, and JavaScript. Alternately, if you really want, you could do let my name colon space string, and then later my name equals JavaScript, or my name equals Josh Goldberg. So if you want to assign a value to my name that is a string, TypeScript will allow it. And then if you assign a value that's not 1, 2, 3, 7, let's say, because you have declared previously that my name is only allowed to be a string, TypeScript will yell at you saying, hey, number is not assignable to type string. So this is a way that you can add some syntax to your code to have TypeScript enforce things for you. It can be your bouncer. It only lets in things that you say are allowed in. In this case, strings. My name is not allowed to be, say, a number. If we don't add in the colon space string, my name is allowed to be whatever the hell you want, which is any. The any type is the I don't care, TypeScript shut up, let me do whatever I want type. And that's a lot more permissive, no bouncer. Thank you, Chelsea. Any questions or comments so far? Cool. So to recap, TypeScript understands what type your things are. My name here is inferred to be type string. And then if you add a type annotation, which I have explicitly checked in the source/3 example, TypeScript can give you better inference on it. In this case, it acts as a bouncer. Better name is only allowed to be a string. And I also want to note something very important, that anything specific to TypeScript in the syntax world, any colon space or whatever nonsense, that's only a development helper. It doesn't exist in the output JavaScript. Because again, TypeScript compiles down to JavaScript, which has to run in browsers, can run. And browsers don't have any concept of types. That hasn't been added to the JavaScript language. Internet Explorer 11 is not going to get support for TypeScript. So if I'm running TSC in watch mode, and if we go to my files view and look at the compiled output for this file, which is 2.js, we can see that TypeScript is turning the let into a var because that's old JavaScript, fine, whatever. It's saying my name equals these things, and it's removing the colon space string. The thing on the right is JavaScript, and the thing on the left is TypeScript. TypeScript is a superset of JavaScript, so the thing on the left has string, but JavaScript does not. And I also want to note that TypeScript is actually a relatively unusual language in that it can still compile to completely valid output, in this case, JavaScript, even though there are very obvious, clear, wrong complaints in the file. This my name variable has 3 errors here. There's a type error that you're giving it a number. There's a type error that you're asking for a len. There's a type error that length is a number, not a function, meaning it's not callable. And yet we still have JavaScript on the right.
So
that's one of the cool. Oh, go ahead.
Sorry, I just wanted to get some more clarity on length in TypeScript. Like it's a number, like how is that used properly in TypeScript? Like what number is it?
Sure. In JavaScript world, every string has a length property.
Right.
So I'm actually gonna open a node terminal on the right. So value equals hello, value.length is 5. So TypeScript doesn't care about the particulars of like what the length is, like which number generally. TypeScript knows that because you have a string, it has a member named length whose value is some number. So if we do my name.length and then set it to a variable, let my length equals my name.length, and then we hover over it, we see that TypeScript can infer that this is type number because my name.length is a number. Okay, is that the direction you were going for?
Yes. Thank you.
Awesome. Good question. Any other questions or comments? Cool. So to recap, colon space is how you declare that something is a particular type. And those types are often primitives like string or number. And later I'll show more advanced types. And they don't, those annotations get removed when they get compiled to JavaScript. Now, sometimes you have a value that might be one thing or another. And you might want to say that this can be, say, a string or undefined. So here we're able to say that the name maybe parameter for this takes name maybe function is type string or undefined. So I'm cheating here a little bit. I'm introducing two concepts at once. For starters, I'm introducing that function parameters can have type annotations. And I'm also introducing that type annotations can be what's called a union or multiple things. And I'm going to quickly pop back over to VS Code for 4.ts. Here, TSC source 4-w. So here I'm saying that this name maybe parameter is allowed to be string or undefined, meaning I have put this type annotation on a parameter. And to be clear, the places you're allowed to put a type annotation are in a parameter, or I should say on a parameter, on a variable, or on a class member to be shown later. Oh, my auto formatter is running. So this takes name maybe function, takes in a parameter that can be either string or undefined. So if you want to call it with takes name maybe undefined, that's allowed, and takes name maybe some gibberish, that's okay. Any string in the universe will do. And because name maybe is string or undefined, if you ask for some member of it, TypeScript will yell at you saying, hey, I know that this might crash, because if you call me with undefined, then this code is not going to run, it's going to crash. So that's one of the benefits of TypeScript, that it can tell you, hey, if something isn't guaranteed to exist, asking for a member of it will crash.
Hey, Jeff, sorry, can you zoom in a little bit, please?
Oh, I'm sorry. Is this good?
Yeah, that's much better.
Awesome. Thanks for letting me know. So if we look at 4.js and, whoops, right click, copy relative path, exit out of node, and then run this thing in node. Why is my paste not working? Yeah, source 4.js. The compiled JavaScript crashes because name maybe is undefined, and we can't read properties of undefined, trying to read length. And TypeScript told us ahead of time, hey, that's going to happen. It's going to crash. Object might be undefined. Before I go into this if statement and the concept of type narrowing, does this concept of undefined and types being one or more potential types or values being one or more types make sense? Any questions or comments? I like that too, the Chicken Little of TypeScript, or of JavaScript, pardon me. Cool beans. So now that we know that a value can be one or more possible types, in this case, it could be either string or undefined. We might be able to also say it's a number or string or undefined. TypeScript introduces the concept to JavaScript of type narrowing, which is a development time thing where if TypeScript sees that an area of code can only be hit if some condition is true, it will assume that condition is true. For example, in this if statement, we say if name maybe. Inside this if statement, this code can only be run if name maybe is truthy, which means it's not going to be undefined in this if statement because undefined is false. So the contents of the if block wouldn't be run. So name maybe must be a string. Fun fact, it has to be a string with a length greater than 0 because the blank string is falsy in JavaScript. So inside here, if we console log name maybe.length, that's okay because TypeScript knows that name maybe must be a string in this if statement. I'll pause there. Does that bring up any questions or comments? Okay. So this is a concept of type narrowing, where within an area of code, within a block, TypeScript is able to infer that something is a more specific type than it previously thought. Type unions. So I've introduced the concept of parameters. Let's talk about function types. So far, I've just shown, I think, the type string, undefined, and then I briefly mentioned number. We should probably cover what the basic types of TypeScript are. And the basic TypeScript types align to the types of primitives in JavaScript. And I like a little bit of interactivity in my workshop. So I'll give you one example. One example of a primitive type in JavaScript is string. Can anyone name another primitive, either out loud or in the chat in JavaScript? Array, great question, great point. I'm actually going to save that for later. Array is a type in JavaScript. It's actually it's like a halfway point between primitives and classes. There is an array type, and there's also like the array syntax. So yes. Does anyone have another type in JavaScript? Someone just DM'd me, either on purpose or intentionally. I will maintain anonymity. Number, yes. Number is another type in JavaScript, and it is a primitive type. And fun fact, JavaScript recently added the concept of big int, which is like number. Cool. I will spare you all the pain of having to answer these random callouts. There's also Boolean.
Yeah.
Boolean, big int, number, string, null, and undefined, which are, I believe it's the unit type is the term. There's only one of them. It's just null is the type and the value. There's also symbol, but we don't talk about symbol. No. That's like this real complicated thing in JavaScript I don't like to go over. I think there's 7. There's one more. Oh no, that's 7. I might be missing one. Anyway, all of these in JavaScript can be declared as a type of something in TypeScript. You might say, let's my whatever. Look at that beautiful VS Code feature there with the multi-cursor. These are all allowed as type annotations. So if we say my Boolean equals blah, 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 that's not allowed, but my Boolean equals true. That is allowed. However, this is only basic values. This doesn't go over, as mentioned, arrays or objects or functions. So let's just real quick introduce function syntax. In TypeScript, the way you declare the type of a function is pretty similar to the arrow function or arrow lambda, previously often referred to as fat arrow syntax, but we've stopped using that for obvious reasons, referring to the name. The thing starts with a left parentheses, has a list of parameters, if any exist, right parentheses, arrow, and then the return type. This slide declares that the process variable must be set to a function that takes in one parameter, a string, and returns back a number. So if we say process equals takes an input, returns input.length, we can infer the input is type string. And then if we try to assign it to something that returns some other type, like a string, then TypeScript will yell at us. Cool. So this was number 5. Let's look at 5.ts, tsc source 5-w. Here we have process is this type. And fun fact, you can also declare a value, excuse me, you can declare a variable set to a function and add type annotations in that function. Here, let's call this other process. Here we're declaring this other process variable whose type is inferred to be a function that takes in an input string and returns a number. And if you mess up the return type, if say you forget to add a return, TypeScript will yell at you saying, hey, you have a declared type, ignore that other stuff, must return a value. Or if you return blah, 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 TypeScript will yell at you saying, hey, you said it's supposed to be a number, but it's string. So that's function types. TypeScript lets you declare what type of function is supposed to take in or return, or just what a function is supposed to be in general. Any questions or comments so far? Cool. I will note some functions don't return a value. Function fancy log might take in an input string, console.log, hello input. This thing, this fancy log function doesn't return a value, doesn't have a return statement. So the term for this is void. Void means this function doesn't return a value. Now, in JavaScript, implicitly functions return undefined, but TypeScript lets us declare not only does it return undefined, it doesn't actually return anything at all. So if we hover our mouse over this thing, we can see that it's : void as the return type. That's the syntax. And then if we wanted to declare a variable that returns void, that takes an input string and returns void, that's allowed. Cool. And because returns void is a variable that's supposed to be a function that returns void, if we try to return something, oh, fun fact, it is allowed. But if we try to use the result of it, this variable will be type void, which is very confusing, and it doesn't let you do anything with it. So in that way, TypeScript stops us from messing up if a function is returning void, so no value. I personally find the difference between void and undefined to be kind of confusing. So in my mind, I think of them as the same thing, but there are like weird little intricacies once in a while you'll see with it.
So if you don't declare a return type in TypeScript, it assumes void by default.
If you don't have any returns, it'll assume void by default. Oh, good clarification. But if you don't declare a return type, it will infer the return type from all the statements in the function. For example, if we return null here, TypeScript will infer that it returns. There we go. It returns null. And actually, here's a fun fact. If you want to do, let's say, multiple returns, TypeScript will look at every return in a function and figure out what all the possible return types of that function are if it has to infer. So here it is inferred that this fancy log function will return either true, which is the literal type true, or null, which I think is kind of nifty. Nice little feature. Is that what you were looking to explore?
Yeah, that makes sense. Thank you.
Cool.
So you don't end up declaring a return type in TypeScript the way that you would in like Java or Rust. It infers it for you.
Yes.
Okay.
I should note that there is some debate and lack of consensus in the TypeScript community about when and where you should declare type annotations. Some people prefer every function always has a return type declared explicitly because it helps for documentation. You can just scan the one line and see all the information about the function's input and outputs. And then if you mess it up later, it tells you in the function rather than somewhere else. I personally prefer not doing it because I think the less code you have to write, the better. And if you need to change things, it's less of a pain if you don't have explicit types that you have to change also. Mm-hmm. It's personal preference. My recommendation for folks who are getting started with TypeScript is to let TypeScript infer as much as possible, because sometimes TypeScript can be smarter than you. Like here, I might have written returns Boolean or null, but TypeScript can actually infer that not only does it return Boolean or null, it technically actually returns true or null. It's never going to return false. And actually, that brings up a really interesting point. I want to talk about literals versus primitives. In TypeScript, we've seen values like let my value equals 1337. TypeScript infers this to be the type number. But you can tell TypeScript that something is more specific than just any number in the universe. You can tell TypeScript that something is literally an exact number. You can say that it's either 0 or 1 or 2. Let's actually let my status is 0, 1, or 2. So now TypeScript knows not only is this a number, it can only be these literal numbers. It can only be 0 or 1 or 2. So if you try setting status to my value equals 1, 2, 3. Oh, wrong one. My status is 1, 2, 3. TypeScript will yell at you saying, my status is type 0 or 1 or 2, and 1, 2, 3 is not assignable to that type. That's the difference between a primitive, which is general basic type in TypeScript and JavaScript, such as number, string, and a literal, which is specific example of a primitive, like 0 or the blank string or a hello world. And TypeScript understands the difference between them. And if the really cool thing about variables here is that let variables default to the primitive type, whereas const variables default to the literal type. Const my const value equals 1337. Because TypeScript knows that this variable is never going to have its value changed, it knows that it's not just the number type, it's specifically the literal 1337.
I was literally getting ready to ask you that, but you hit it.
Awesome. This is a concept that's starting to become really important in a lot of newer programming languages like Rust, which actually I just got the really big Rust book. I'm excited to learn it. I know Swift is also a big thing on null safety and literals and primitives type stuff. C# just added that. So this is like a new fancy thing for programming languages. A lot of older languages like old Java and C# and C++ don't really understand the difference between those things. They don't have the concept of a type union.
That is true. It is worth noting that as of about 10 years ago, Java does have an optional type.
It does have an optional type. That's right. I love it. We should talk about the $1 billion mistake because this is the perfect segue to it. Thank you. Does anyone here off the top of their head remember or know what the phrase "the $1 billion mistake" means in programming? This is a random piece of history trivia.
Yeah, I've heard of it. I don't recall.
Darn, I was hoping someone would because I don't know how to properly pronounce this guy's name, but I'm gonna say his first name, Tony. Tony, I believe it's Hare. He invented a whole bunch of old programming stuff back in the 60s. And one of the things he invented was the concept of a null reference, that a value might be my other thing, or value equals null. And fun fact, in JavaScript, we have two things that are equivalent to null or nil or undefined, and it's been a pain in the butt ever since they added that. I disagree with it, but fine, whatever. And Tony regrets this greatly when he invented it, and all bunch of languages now have the ability for something to be null. Because one of the really common interview questions people give is hey, how could this function, let's call it log text. How could this function crash? Well, if you log text with null, then it'll crash. So at the beginning in a lot of older languages, in the beginning of every function, you're supposed to do if text is null, throw new error, blah. So a lot of programming happens when you think that a value is defined and it's not, and then you get a bug. That's a lot of time spent in programming. So older languages don't understand that if something is declared to be, let's say, type string, you're not allowed to assign null to it. Null is not an okay value for a string because null doesn't have the properties of a string. Newer languages like TypeScript and Swift, and I believe Rust, have this concept where if you say that my value is, let's say, a number, and you try to assign undefined, or in JavaScript, either undefined or null to it, TypeScript will yell at you saying, hey, you're not allowed. Type null is not assignable to type number. So fun fact, TypeScript does not enable this by default. but there is a flag called strict null types that TypeScript can run with, a compiler option that enables it. It's only not on by default for backwards compatibility reasons. They didn't start off with it. And before I go into TypeScript compiler options and the like, does this billion-dollar mistake, which Tony refers to, the amount of damage he thinks he's caused by this, make sense and seem reasonable? Any questions? Cool. So before we move on, I do want to note TypeScript is generally configured in a tsconfig.json file. We don't need to go too deep into it. There are a lot of like weird little intricacies that you can read up on this URL about it. I think this URL still works. Yeah. The one note is that TypeScript can run with more or less strict settings. And one of the more strict settings is called strict null checks, which changes whether null and undefined are or are not assignable to other types. If you set it to false, the default, which is unfortunate, and then try to assign null or undefined to a value that's not allowed to be them, then, well, TypeScript won't complain, which is bad. So you always want to have this on. Yay. Any questions or comments so far? Cool. Function types. Next up, objects and interfaces. In JavaScript, it's very easy to make a new object. In this example, we're creating the SpongeBob object and assigning it to an object literal, which has two members. It's got a greet, which is a function that says I'm ready, and a name, which is SpongeBob. And TypeScript is meant to work with all sorts of JavaScript, so it has to have a way for us to describe object types, similar to how it has a way to describe function types or other types. So this interface syntax is how TypeScript lets you declare the shape of an object. When we have this line set, this block of code in TypeScript, we're saying, hey, if I ever describe something as being the person type, I am telling you that it has to have at least two members. It has to have this greet function member, which takes in no parameters and returns void, nothing. It's a function. And it has to have a name string. And a TypeScript will allow any object that happens to match an interface, in this case, the person one, where the interface is needed, where something is declared to be that interface type. So looking at the code example, let's go to line $1 billion. Let's go to file, pardon me, 6.ts. Boop, boop, boop. I am here declaring interface person. And now I'm declaring later on this value, this variable SpongeBob, which is type person. And because it's of type person, it's allowed to have greet and name. And in this function log person, which takes in a person, because I've said that this parameter person is the person type, TypeScript knows that .name is a string and person.greet is a function that returns nothing. If I were to say call person.cook, whatever, TypeScript would yell at me saying, hey, property cook does not exist on type person because my person lowercase p is type person uppercase p. And fun fact, TypeScript is what's called structurally typed. And I'll get into in a little bit the difference between structurally typed and duck typed and strictly typed or statically typed in a little bit. This Patrick value, which I'm just going to collapse some code to get closer to, this Patrick variable value here is an object that just so happens to have greet and name that just so happen to match the person interface. Its structure just so happens to match the interface, which means it's allowed to be used wherever something requires the interface. And this is very different from older languages, if you use them like C# or Java, where this is structural matching. If anything happens to have the satisfying members of this interface, it can be used in place of one. So this log person function just cares that the person happens to have greet function and name string. So this Patrick value happens to match it. Now this plankton value, unfortunately, does not. Plankton says announce instead of greet, and log person, therefore, would not allow it because argument of type, it has announce and name, is not assignable to parameter of type. parameter of type person, because it's missing greet, which is a required member of the interface person. So that's structural typing. In TypeScript, we don't say this object is specifically exactly an instance of this interface. We say, hey, I'd like things that match this structure, and anything that happens to match it is fine with me. It's much more chill, which I realize goes against the earlier bouncer analogy, but as the Russians say, every analogy walks with a limp. Any questions or comments on structural typing and interfaces? Cool. So this actually brings up a really fun discussion, maybe. Should you type variables with explicit types? Does it make sense to say that my SpongeBob and my Patrick and my Plankton variables should be type person? Sometimes that might be useful. For example, we would have caught earlier in our development experience that Plankton is messed up. Plankton is supposed to be a person, and if we had added an explicit type annotation to Plankton, saying it's type person, then this announce thing would have been complained about. Object literal may only specify known properties, and announce does not exist in type person, which is actually a behavior of TypeScript. If you say that something is a particular interface type or object type, and you add some unknown value to it, then that's not allowed. It'll say that unknown member, that property does not exist. So that will hint to you that, hey, your announce is wrong. And if you were to delete announce, then it would tell you, hey, Plankton is supposed to be a person, but it's missing greet. Oops. Also, a little fun trick about TypeScript that I've come to really appreciate. Sometimes it'll tell you when things are almost right. It's like if you say gret instead of greet, TypeScript will be like, hey, gret does not exist in type person. Did you mean to write greet? And it'll have a quick fix, which you can get to either with the shortcut it says on the screen, or by clicking here, or by clicking on the little light bulb. Oops. Quick fix. Oh dear. I guess this one doesn't work. Well, never mind. Sometimes it'll have a quick fix that like fixes typos for you. And I guess mine isn't doing that right now. Oh, well, I swear this worked last week. Anyway, if we do plankton.gret and then do the quick fix, there we go. But when the light bulb is blue, it'll offer to change spelling. You'll have to pardon my extensions with the typo corrections. Cool. So that's an example of some of the more powerful development help that TypeScript can give you. If you have a typo, you can change spelling to the correct thing automatically, which is, I think, like a really useful tool that TypeScript gives. Cool. Any questions or comments so far? All right. So it is on my clock exactly 1:00 p.m. We have half of the thing remaining. If no one has any questions, or if we have time, my default would be to go over arrays next, because we didn't actually talk about those, and those are very important. And then some more, I don't like the word advanced because that has a difficult connotation, but like complex or fancy types, things like generics and type modifiers. But I want to pause before doing that and ask, does anyone have any questions they want to ask or particular things they want to cover?
I don't know if it's part of this, but using TypeScript with React.
Yes, that is actually a great transition. Fun fact, much of this workshop is pulled from a workshop I did previously with someone else where we transitioned directly from objects to doing TypeScript with React. So this is very fortuitous. Let's make a new React file. Ooh, great question in the Zoom chat. I'll cover that next. JS doc is really cool. So let's talk about React. So fun thing about React and TypeScript, if you want to write JSX code, which is for those who haven't used React before, when you do stuff like this, it looks like HTML. You have to have a .tsx extension in TypeScript. It's a long story. TypeScript used to have a piece of syntax that I haven't covered yet that conflicts with JSX. So now they have a different extension when you want to use JSX instead. TypeScript should just natively work with React with a couple of caveats. One is that you have to have a TSX extension. The other is that in your TS config, you have to specify how JSX is supposed to work. Because there are a few different ways that JSX could work. It could be that you want to use React specifically. You might be using a different library like Preact. I don't know of any other libraries that use JSX, but I know they exist. So first of all, you have to provide a JSX flag, which we can put in compiler options, JSX. And then that gives us a few options. The most simple one is preserve, which says in your output code, just leave it as is. So let's, there it is. TSC source react-w. And then if we open react.js, we see that the JSX is preserved. If you're using TypeScript as a part of another tool chain like Babel, Create React App, whatever, Webpack, then it doesn't really matter as long as there's a value because someone else is going to turn your TypeScript code into JavaScript, not TypeScript, or not TSC. So this is just going to work. And if you const my other component, let's call it a parent component, return my component. If you have components that render each other, that's allowed. The way you declare props is typically with interfaces. There are like a few slightly different ways of doing this, but the most common one that I like is with interfaces. And I like just going with the naming convention of interface, whatever the component's name is, props. So let's say my component is supposed to have like a count. So actually, let me simplify this a little bit. You can say like props for the function is my component props. And then let's say there's like count, which is a required number. And then we like render counts. Props.count, there we go. Now that TypeScript sees that this component is supposed to have a required count member of its function parameters, which in non-React terms is saying it's supposed to take in an object that has a count member. If you're missing the count prop, it's almost as if you're calling my function or my component as a function. Property count is missing in type. You gave it nothing, but required in type my component props. This error message isn't great actually, but it means that you forgot to pass count. So my component count equals 3. Otherwise, TypeScript should just, with big quotes as always around the word just, work with React.
So it's looking for this JS. Oh, I'm sorry.
Oh no, go ahead. I was about to move on.
Seeing how it's looking for this JSX flag.
Yes. In your TS config, you can specify JSX. If you do JSX React, I want to say it'll. I guess it doesn't really change much, but yes, alternately, you could also provide JSX on the command line. So TSC source /react -- JSX preserve. But the downside of providing flags on the command line is that VS Code doesn't know about it because VS Code and other editors read from your TS config. So I always just put it in the TS config. Is that what you were looking for?
Yep.
Cool.
Thanks.
Awesome. I do see the Zoom question in the chat. I want to dive into one more quick thing on React though, because it is required for React, required-ish. Not all JavaScript packages are written in TypeScript. A large number aren't. What a world we live in. But TypeScript still wants to understand those packages. Let's say that you use like imports React from React. How is TypeScript going to know what shape the React package is? How does it know that it has a default export named React? And then like React is supposed to have like a React.children or like React.React node interface or something exported from it. So the way that the community has solved this is that for packages that weren't written in TypeScript, we have this giant community website called aka.ms types, which is an interface on type of this giant community repository called Definitely Typed. Definitely Typed is one of the biggest repos on GitHub, which I think is actually really cool. And it has these community written type definitions for all sorts of JavaScript packages. It's open source, anyone can contribute. Quickly, someone tell me their favorite JavaScript package.
Left pad.
Left pad, how dare you? Let's look for it. Left. Oh, I guess left pad isn't on definitely type. Okay, cool. Let me look for an AKNMS type. So left pad is a JavaScript function package. Oh, left dash pad. JavaScript package that someone deleted the contents of a couple years back, and it like broke the internet. It was this whole thing. You can read news articles about it. So AKNMS is a search engine where you can see for any package, does it have its own types? So some packages do have their own types. They come with them. And some packages, the types are authored in DT. That's a little DT icon, short for definitely typed. So like, I guess I'm tempted to look at pad left because I think it's funny that the package names are like that. But like looking at, let's say the repeat string package here, this gets published to NPM as a package that has this DTS file. So if you want the types for a package and you're using TypeScript, people are able to publish .d.ts, short for declaration file, declaration TS file, which says how the function looks. I'm going to zoom in. In this case, the repeat string package looks like it has a function that's declared that takes in string and number. This question mark means a parameter is optional. That can be a number or string or null and returns a string. And then this repeat string package gets published to NPM as NPM types repeat string. So if you want to use this repeat string package and your project is in TypeScript, you can install this at type/repeat string package, and TypeScript will read this to understand what the repeat string package looks like. Alternately, left pad itself, I believe, comes with its own type definitions. So here we go. So like a package can provide its own type definitions. So either they come from definitely typed or the package itself. I bring this up because React is not written in TypeScript, and therefore at type/React is one of the most popular type packages you could use. So if you want to use TypeScript and React together, I would highly recommend npm install save at types React or save dev types React, which means now your TypeScript project should recognize that the React types exist. Now you can do like children is type React.React node. Fun fact, that's boy bay. That's how it's supposed to work. Well, my VS Code is being weird, but anyway. So the things you have to do to use TypeScript with React are use the .tsx extension, set your JSX setting in your TS config or on the command line, and install the at type/React package so TypeScript knows what the React package looks like.
Cool. Thanks.
And I'll have links in the repo to a good guide to that. Any questions or comments on that? Cool. So Makeda asks in the chat, I've seen things like at param, at summary, what are these doing? Yes. Let's look at a new TypeScript file. Actually, let's look at JavaScript. Let's say you have a function, I don't know, function bake cake that takes in flavor and a size. And this is just JavaScript, vanilla JavaScript as they call it, meaning no flavor, no types, not TypeScript. Previously, people made this standard called JSDoc. By the way, VS Code supports it really well. So if you start typing in /*, it'll give you this suggestion. And if you hit enter or click it, it'll fill things in. And at param, flavor at param size lets you how big in inches or whatever, how it lets you describe the stuff that you're writing this function, the parameter, and returns a description of the cake, let's say. So now in later JavaScript, if you start typing bake cake, VS Code and other editors will be able to pick up on these JSDoc, JavaScript documentation comments, and show you the person who wrote this function said that flavor is the flavor of the cake, and it returns a description. Now, a cool thing about JSDoc and editors like VS Code is that it's powered by TypeScript and it recognizes types. So what a lot of people do is they'll add in under curly brackets the type of things, param string, param number. And now this function knows that flavor is type string and size is type number. And even before this, actually, fun fact, TypeScript was able to infer that bake cake returns a string because that's the only thing this function can return. But once we add in the JSDoc type annotations, it can also tell us flavor and string. Sorry, flavor and size types. And there are a whole bunch of tags like this. Param declares a parameter, returns says what a function returns. You might creates a description. At summary is a common shorthand people do for like just summarizing what something does if it's really complex. There are also other ones like to do, make this actually make a cake or whatever. And in VS Code and other editors, they give you a list of the common ones when you start typing add. So if you really want to learn about all these things, that could be fun. Version 0.1.2. TypeScript is generally strong enough so that if you're writing TypeScript, you don't need to do at param string. Like this doesn't make sense in a TypeScript file, but it can sometimes, actually oftentimes still be useful, especially for function parameters to annotate them with these types. Like if I made a cake.ts file and did bake cake, I might still keep these in, even though I don't need to put the type in the comment because I can make the type in TypeScript. So that's nice. I'll also note that these don't have to go on functions. They can also go on variables. What's someone's favorite cake flavor?
Vanilla.
Did someone say vanilla? I couldn't hear, sorry.
Yes, that was me.
Yeah.
Vanilla. I take my cakes like I take my JavaScript. Vanilla, which is a lie. I prefer fancy cake flavors, but I'll allow it. So like this, my favorite cake flavor. Like you can put them on variables. And in fact, in JavaScript, I believe there's a type that's allowed. So like let my cake equals, yeah. At type is recognized by VS Code. Does that answer what you were looking for? Any other comments, questions on this?
Yes, I think it does.
Awesome. I believe these came from JavaDoc, which looks the same but is used for Java. And now there's also a work in progress standard for TypeScript called TSDoc, but that's not moving very quickly, so everyone just calls it JSDoc still. Fun little thing about TypeScript, you don't have to use the TS extension if you want to use the TypeScript language. You can have TypeScript run on your JavaScript files, cakevanilla.js. If you in your TS config or on the command line specify allow JS to true, TypeScript will allow itself to be run on your JavaScript files. And then if you do check JS true, it'll actually check your JavaScript files for complaints. Like if you have a type annotation that doesn't exist. Oh, here's a good example of the did you mean. I didn't even notice I typed numbers instead of number, and it can quick fix to number. And then here I forgot a parameter again. Classic 12-inch vanilla cake. So this is actually really useful if, say, you have a project that's written in JavaScript and it has like 5,012 lines and you don't want to convert them all to TypeScript at once. At Codecademy, we converted from JavaScript to TypeScript in 2019. And we did it by incrementally changing a few files at a time over to TypeScript over the course of a year using allow.js.
And I'm sorry, Josh, what is this at stuff called? Is there a name for it?
I actually don't know. I call it like a JSDoc tag. I don't know if that's, does anyone, if someone can correct me, please do. I don't know the official name.
Sounds good to me.
Tags. Okay. Tags, jsdoc.app calls it tags. Okay, cool. And actually, this is a good website for me to link here too. Boop. Cool. Tags it is. Anything else on JSDoc, JavaScript support, that type of stuff? Cool. My next steps will be to talk about arrays and then classes. Someone stop me. Okay. Arrays. This was mentioned earlier as a type, and yes, they are important. TypeScript has a nice syntax for declaring something to be a type of an array. Let my flavors string equals string. This is how you declare an array type in TypeScript. You say whatever is allowed inside the array, and then the empty array brackets, left square bracket, right square bracket. And now if you do my flavors dot push, TypeScript knows you're allowed to push any number of strings. Fun fact, the array push method can take in any number of items, not just one. And this little dot 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 syntax is actually something I didn't cover before. Function rest parameters in JavaScript, like function take flavors. In JavaScript, you do a dot 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 to say something that is vanilla, matcha, coconut. I recently got a matcha coconut cake, and let me tell you about how my life changed after that moment. That says it's allowed to be any number of flavors. Pardon me, any number of parameters. And then all rest parameters are an array. So my flavors dot push chocolate. And for const flavor of flavors, my flavors dot push flavor. Let's just log it to justify using this thing. Cool. So when you have an array, whether it's an array like a variable or like a rest parameter, TypeScript knows that each item in that array is whatever type that array is declared as. So if you loop over them for flavor of flavors, now we know that flavor is type string. And flavors.push, my flavors.push is supposed to take in a string. If you try to push something like null, you're making $1 billion mistake here, then no, that's not allowed because the function is supposed to take in a string. And let first flavor equals my flavor is 0. Because my flavors is a string array, we know that this thing takes in a, or is a string because it's an item from the string array. Before I start complaining about how this is super unsafe and arrays are weird, any questions or comments?
Waiting for the big reveal.
The big reveal. Yeah, so what happens if you do this? Console.log best flavor ever. And I'll just comment, or I'll just ignore the rest of it. Does anyone want to guess what will happen in this line of code if we try to compile to JavaScript and then run? What the heck are these? Oh, my at types is weird. If ever you get weird compiler errors or weird node things, just remove your node modules directory. In this case, I'm going to remove the types React package because it's being weird, and npm install again, the equivalent of turning it off and on again. Anyway, this code will crash if we compile it to JavaScript and then run it. We are saying my flavors is an array. My first flavor, note again, the type annotations are removed. My first flavor is my flavor 0. And then we try to, actually, sorry, it won't crash. We'll just log undefined. Node source arrays.js. Because the first member of the array, TypeScript thinks is a string, but we know this is actually an empty array. So this is an example of TypeScript not being a sound type system, meaning there are times when it's surprisingly easy to trick TypeScript into being wrong. In this case, intellectually looking at this code and seeing what happens when we run it, we know that the first flavor variable is actually undefined. because we're getting the first value of an array that has nothing in it. Another example would be like, if we have this huge number, this is definitely undefined. We don't have that many flavors. But TypeScript is a pragmatic programming language, so it doesn't try to always be super strict and yell at us if something could even slightly possibly be wrong. It just assumes, okay, in this case, arrays are so commonly used, you probably know what you're doing. There is actually a relatively new flag in TypeScript under the strict family. What is it? Unchecked index access. Yeah, so TypeScript can run in a way that tells you like, hey, you're doing arrays wrong, but it doesn't always catch everything. Here we go. It tells you, hey, if you're not sure whether a member of an array exists, it will be or undefined by default. So that's like an extra level of type safety, but that is so incredibly annoying if whenever you get something from an array, it's or undefined by default, that most people don't turn this thing on. I personally don't. So that's fun. I'm just going to go ahead and turn that flag off. But arrays are really cool and useful. And in TypeScript, function log array, or let's make a new one. Let my dates, you can do unions in your array, date or on string. My dates dot push sep 13 1993. My dates dot push new dates 2022 0205. Dates are hard. Oh yeah, fun fact, TypeScript will yell at you if you forget to create an initial value for something. And also fun fact, TypeScript will default array types to never, meaning if you didn't declare a type for your array and you just say it's an empty array, TypeScript doesn't know what you want in it, so it'll default it to never, meaning nothing is allowed in here. So with this union type of the array, my dates is allowed to be either a date or a string. Free const date of my dates. If we loop over those dates, each one of them is going to be either a string or a date, because each member, each item in the array is a date or a string. And then we can use type narrowing if type of date is string, date dot to uppercase. We know that inside this if statement, date is a string. And if it's not a string, it must therefore be date with an uppercase D. So arrays can have union types in them, and then you can retrieve members of those arrays and perform all the usual TypeScript fun, such as type narrowing. Any questions or comments? Cool. Off the top of my head, I think there are two more things I'll cover, and then I'll stop after that because this is a lot of info. Classes and generics in that order. Classes is a good segue because we just saw new dates. Now, back when TypeScript came out, JavaScript was still really new, or sorry, modern JavaScript was still new. Things like classes weren't frequently used in the language. They weren't technically available in the language yet. So TypeScript bragged that you can use JavaScript features like classes today, and people misinterpreted it to say that TypeScript adds classes to JavaScript or makes you write Java-like programming when you write your TypeScript files. Totally false. TypeScript does not enforce any kind of particular architecture on your app. You can use functional programming, you can use object-oriented, you can use classes, you can use no classes, whatever you want. And I want to make that clear because once in a while, you'll come across someone online who hasn't updated their opinion of TypeScript since like 2013, who will yell about this. And I want you to be prepared to shut them down, yell at them back. Feel empowered to yell on the internet. So classes are a JavaScript feature that TypeScript supports. I want to be very clear on that. It's a JavaScript feature and it's supported. Let's say we have a class, running out of examples here, painting, with like a painter, or let's call it painted by, and then an owner string and year number. Constructor, and I am writing some sick TypeScript syntax here. Boop, boop, boop. TypeScript allows you to declare the members on classes. Oh, actually, I wanted to give these all the same types. This painted by. There we go. So when you declare a class in JavaScript, you declare it like this. You don't add any members to it. But in TypeScript, everything needs to be well typed. It needs to know what are the allowed members on this class. Similar to how if you were making an object that was like supposed to be an interface, you would know what members are supposed to be on it. Recall the like, what was it, 6.ts, we had the interface person. We knew that greet and name should exist. So for classes, you declare as a member each allowed member property with its type. And TypeScript will yell at you if you access a member of the class that's not one of those. Like if you try to do this dot value equals 1, 2, 3, TypeScript will yell at you saying property value does not exist on type painting. And otherwise, it actually is pretty similar to the rest of TypeScript. The constructor of a class is a function that happens to take in particular parameters and assign to this often. And then if you try to do new painting and you mess up the function parameters, TypeScript will yell at you just like with a normal function. It'll say argument of type number is not assignable to string if you pass a number instead of a string. Cool. One cool thing with classes is that although it doesn't actually do anything with your code, you can say that a class implements an interface, which means you're asking TypeScript to make sure that some fields exist on the class. And actually, I want to show you, if we change our tsconfig to output code that supports only browsers that are like ES 2020. So like a relatively new browser syntax support, which means we don't compile this down to like old JavaScript. Do TSC source classes -w, and do classes.js. Come on. There it is. We open classes. Oh boy. Okay, cool. So this is actually what the equivalent in JavaScript looks like to a class. Notice, first of all, that in JavaScript, the classes are just syntax sugar for functions. Where if there's like a member function there, let's say like announce is me, like it's actually added to the JavaScript prototype of the function. That's just how JavaScript classes work on the inside. All these member annotations don't exist in JavaScript. They're a TypeScript only syntax feature. And then this art interface and the implements art disappear. So that's cool. This is important to note because JavaScript classes are like kind of a controversial feature. Some people really like them. Some people try not to use them. So note that TypeScript supports you declaring what is allowed on a class. And I'll stop there. Any questions or comments? Oh, actually, one more thing. If the reason why you want to implement an interface is because let's say an interface is supposed to have like, let's say add a value, some member that the class doesn't. If you forget to implement all of the interface, if you forget to have a value for one of the interface's things, TypeScript will yell at you saying you messed up the interface implements. Let's say the art one has a value and you forgot to add it to your painting. And then a quick fix might be to finish implementing it by adding value number. Ta-da. And actually, I thought I configured my TypeScript. So TypeScript can emit JavaScript. Its compiler can emit JavaScript that is not supporting older browsers. So if you set target to ES 2020, I want to say, and resave your file, in theory, this should, well, in theory, this should output like class painting, but I guess I don't know how to do that anymore. Never mind. TS configs are hard to keep track of. Any questions or comments on classes? Cool. I like ending workshops with a like fun brain teaser thing that is good because it gets people to see like cool things at the end, but it's bad because that makes sometimes people think that they have to understand or use the cool things. So I'm going to show a feature called generics, which you definitely don't need to understand. If this just goes over your head, that's totally fine. But I think it's really cool. And if you come back to it and understand it, it's like kind of fun. To start, I'm going to give the audience a trivia question. Let's take this identity function, text, return, or let's call it thing. Trick question. What type is thing? We don't know.
Right.
Yes. And that's like one of the things, I'm glad that you're in agreement here. That's like one of the things with TypeScript that like, if we don't declare what it is, then TypeScript will let us return anything. New dates, identity, 3, 4. So if we don't declare a type on it, it's anything, which is, I don't know, shut up TypeScript, let me do whatever I want. But some functions are actually meant to take in anything. Like some functions legitimately should take in any. Like, so we could type in any here. Let's call this actually log and return so that it's a little more clear why you do this. I have thing. Let's call this generics. So any is bad because you can do whatever you want. You can do like thing dot blah, blah, blah. And TypeScript's like, okay, that seems fine. TypeScript won't give you a complaint there. The more safe version of any is unknown, which is like any, but you're not allowed to do whatever you want with it. You have to type check. You have to type narrow. You say like if type of thing equals string, thing dot to uppercase. You have to type check it. Oh, excuse me, type narrow it. But some functions, again, legitimately are supposed to take in anything and let's say return anything. So like if we say const first value equals log and return string, and in this function we've returned the string, you would think that first value would be a string. It would be the ASDF string that's passed to log and return because log and return returns a thing. But because we declared the parameter thing is unknown, it's returned unknown. So this brings up the concept of a generic. For some types, functions, classes, interfaces, you might want to say that there is some type T. And each time I call this function, I use this thing, T might be something else. And thing, this parameter might be of type T. So if we say that log and return has a generic type T, and we're going to pass in a parameter of that type T, because the function returns thing, returns the type T, TypeScript can infer that whatever the T is for a function call, that's our return type. Which means this first value variable is going to be type ASDF. And log and return of 0 is going to be generic 0. If we say let my Boolean equals false, and then const return Boolean equals log and return my Boolean, this return Boolean variable is going to be false. Or let's make it math.random greater than 0.5. So we know it's definitely a Boolean. Return Boolean is going to be Boolean because log and return, the generic T is Boolean when this happens. So the point of generics is that sometimes you don't exactly know what a function is going to be called with. They can also be used with interfaces and classes, which I'll show in a bit. But each time it's called, there is a new value for that, or excuse me, a new type value for that type, such as in this case, Boolean on line 21. Any questions or comments so far?
No, you're making everything super clear. So,
yay! Thanks, appreciate it. Let's hide all these. I mentioned you can do it with interfaces. One of the really common examples of generics is used with this type of a box. Let my box, which is box of, let's say, number, my box value 0. That's allowed. That's allowed. My box equals value. Nope, that's not going to be allowed because value is string, but box of numbers value resolves to number because box is supposed to be generic on a T. So you can use generics with classes, with interfaces, with functions. Those are the most common things. Constructor value T, step value equals value. So you could say like new value box of hello. And because you're passing in a string for this class, TypeScript can infer that the T generic is string for that value. Yay, generics. So let's say constant value box, and then my value box dot value is going to be type string. All right, it's 1:37. I've been talking for about an hour and a half, almost exactly. And I think that's pushing the limit of what a human being should communicate to other human beings for. So at this point, I have no more information that I specifically want to give you, but I do want to be here for the next 23 minutes or more. I've got all the time in the world. So are there any projects you would like my advice on? Any questions for me? Any comments?
So can you go over the React, React TypeScript again?
Sure.
Or yeah, I don't recall if you made an example or not.
You know what? Let me actually go ahead and use create React app. Yarn create React app. I just remember this because I did it recently. Oh, someone's car just backfired near me, I hope. That was a loud noise. Sorry if you heard that. Yarn create React app -- TypeScript. Sorry, there are very loud gunshot-like noises near my apartment. It's distracting me. Oh boy. Oh boy. This thing failed. Oh, okay. So if you want to get started with React and TypeScript, typically I wouldn't recommend doing it from scratch, which is true for all React projects. Modern web projects need a lot of tooling. So I recommend a tool like Create React App. So the command I use, I really like Yarn. You can also use Create React App with npm directly. So I'm going to use like Emergent Works, or it's called TypeScript intro Emergent Works React. So that's what this tool is. And the README will have documentation. Oh, see there. Gosh, diddly darn it. Where is my directory? Man, it's failing. Sorry, let me try making this one more time before I look for help online. Maybe I'm doing things in the wrong order. So Create React App, for those who haven't used it, is a really nice utility that will create a very bare bones basic React application that still has a lot of development niceties, like a server you can start with yarn start that will reload the page or components whenever you modify things. Ooh, a great DM. What are some projects, good projects or exercises for learning TypeScript? I gotta admit, I still a little bit of a corporate shill. I think Codecademy is pretty good. Also, looking at all your old projects, like once you learn JavaScript, which I definitely recommend doing before starting TypeScript, ideally you would have had some projects you did in JavaScript. Take those and convert them to TypeScript. That's normally pretty good. My personal favorites, actually, let me start taking notes here of project recommendations while my yarn is installing, is your old JS projects, Codecademy, or free Codecamp, LOL. And then also, I like building Connect 4. My first project, the first language I learned in depth was C++. I did like a Connect 4 C++ game, and that was a lot of fun. It's really useful because it forces you to learn arrays and like printing to the screen, stuff like that. So that's my recommendation. Okay, there we go. My command ran. I finally got it to work. In a rare occurrence, I did not need to look things up online. Normally you do, but I guess I got lucky today. So I'm in this repo. Boop, boop, boop. I hope it has TypeScript. Man, I thought this thing had TypeScript support. You know, I'm just going to look at the docs. Create React app TypeScript. Oh, it's -- template. Dang it. I was so close. npx create React app -- template TypeScript, and it's going to be my app. I'll rename it later and put it online. Oh my God. This is the problem with modern JavaScript tooling, that everything is just like slightly out of date and slightly broken. So like I'm going through the tutorial online and it's yelling at me. Oh my God, this is a nightmare. All I want to do is just TypeScript and React. I love it. Anyway. Yeah, so I'll show the things in this project then. There are 3 things. In your tsconfig.json, set JSX to something. I just use preserve by default. Most of the time, it doesn't matter. I rename my file to .tsx so that it supports JSX syntax. And I also install clear npmi at types/react. So that TypeScript knows what the React package is supposed to look like. So React. Boop, boop, boop. And technically I should have installed it as a dev dependency, but that, whatever, I'm lazy. So before I go into the maybe now working TypeScript React project, is that what you were looking for how to get it to work in a React project?
Yes.
Awesome. All right, cd my app code dot to open it in code. And now there we go. It's got a tsconfig set up for me with a whole bunch of options that you can all look at online if you're interested. It's got app.tsx, which is a function. One cool thing about TypeScript is that a lot of the times there's going to be like almost no TypeScript specific syntax in a file. Like this one doesn't have any TypeScript syntax. It doesn't need it. The function doesn't take any parameters that need to have a return type annotation or anything. And if we run yarn starts, starting dev server, go to localhost, boop, boop, boop. I don't remember my shortcuts here. There we go. Nice. Someone give me their favorite color.
Pink.
Pink. That's one of my favorites too. Yay. Cool. Thanks. Cool. So this is this command that I ran, which should be available online. I'll just put it in the README just in case. Specific C boop. This gets you a nice TypeScript React project with all the things added. In your package JSON, it'll have types React as a dependency, also types just Node and React DOM, because those are other things. It'll actually have tests set up for you, which is really nice, using testing library, which we could have a whole other workshop on if we wanted, and a bunch of other stuff. And then I'm just gonna, for thoroughness, show you what it's like to make a new component in TypeScript. So let's say we have a like color component, export function color, which takes in a label and a value. Let's say I'm just making it up as I go along. Return div my favorite label value, whatever, hashtag value, and then color props, label string value string. So let's do color. By the way, cool thing in TypeScript, if you're working across files with imports and you want to use something that doesn't exist in your file yet, one of the quick fixes it'll provide with the blue light bulb, with the clicking here, or just hitting, I'm going to do it now, enter on your keyboard, enter, is automatically adding imports for you. What a freaking nice feature. So color label equals my favorite color is, Does anyone happen to remember the hex code value for pink off the top of their head?
No, but I know a cool hex code. Ready?
Yes.
C0FF33.
Ooh, what's it going to be?
It's like chartreuse, kind of.
I freaking love chartreuse. Recently had a chartreuse cocktail kick recently because I like making those. Oh no, oh, have to save. Helps to save.
At least I think. It's either chartreuse or magenta. I don't remember, but it's something like colorful.
Cool. Oops. I have a browser extension that lets me pick things. So what was it? Oh yeah, that's a nice chartreuse. I like it. Cool. So yeah, this is a typical component you might write. Sorry, pink, you're out of there. Actually, I'll just put it over here. I like pink. You can call it like a normal component, render it like a normal component, and then you declare interface for the props. Any other questions or comments, React or otherwise? Oh, and I'll post this in the Zoom chat. I'll also put a summary message into Slack later in the thread that has like links and docs.
Eli or Josh, where's the video going to be stored?
Hey guys, so the video is going to be posted on YouTube. What's today? Saturday. We'll try to get it up either by end of day today, if not first thing tomorrow morning. So, and I'll share it in the Slack general channel, as well as the programs channel, so we can all tune in.
Cool. Thanks.
No
Josh,
problem.
are you okay if I tweet about it or blog about it or something?
Yeah, totally. That would be nice.
Yeah, I can run it by you before publication if you would like.
Sure, thanks. I trust you, but doesn't hurt.
The tweet, if I tweet without your approval, it'll just be like, I went to this workshop, link to workshop.
Thanks. Cool. That gives me extra incentive to clean up and write good documentation and helpful resource links on this. So that's probably a good idea.
I don't mean to hold your butt to the fire, but yeah, it's a good workshop.
Thanks. Yeah, since it sounds like we're closing out, definitely feel free to post on Slack, message me on Slack or Twitter or email or whatnot. If you ever have any questions about this stuff, always happy to help.
Absolutely. Thank you so much, Josh. We really appreciate you leading this today. Yo, you guys are amazing, not just as mentees, but just as community members. Thank you guys really in making this workshop happen. And we're really looking forward to providing some other workshops as well. So yeah, stay tuned with us, guys.
Yeah, thanks a lot, Josh.
Thank you. I forgot to mention out loud, these were some awesome questions. It's terrifying giving a workshop when no one speaks, and y'all made it much nicer. So I really appreciate it. Great stuff.
That's the beauty of EW, man. All right, everybody, enjoy the rest of your day. And I'll let you know when the
Good
video's
weekend,
up.
everybody. Stay warm.